let's answer the very important question, what is a VPN? A VPN, or Virtual Private Network, is a way of connecting a computer to a remote network in a secure manner. A VPN is a virtual private network that allows you to connect directly to your home or office private network over the internet. Let's say you are in a remote location and want to access the services hosted on your private network. You can use VPN to do this. VPNs are used because private networks with IP address segments such as 10.0.0.0/8, 172.16.0.0/12, and 192.168.0.0/16 are not routed on the public internet, as these are reserved for private networks only. If you have a router running in your home or office, most likely its internal LAN IP address belongs to one of these private LAN segments, and it is not reachable directly from the internet. A VPN gives you the ability to extend this private network by creating a secure tunnel between the remote client in an untrusted network and the server in your private network. This means that once the session is up and running, the remote client can access all the resources located within your private home network. There are many types of VPN protocols and technologies available on the market today. Some of them are proprietary and need expensive hardware components to be implemented. Some of them are open source and rely on software packages to implement the required functionality. pfSense only supports the software solutions-based L2TP, PPTP, IPsec, and OpenVPN protocols. Why are we specifically talking about OpenVPN? Let's find out. Now let's get familiar with OpenVPN. What is OpenVPN? OpenVPN is an open source software framework which implements VPN techniques, or virtual private network techniques, for creating secure point-to-point or site-to-site connections or tunnels in a routed or bridged configuration and remote access facilities. It uses a custom security protocol that utilizes standard SSL/TLS for key exchange. OpenVPN is very powerful and flexible. Since it is based on standard protocols of SSL/TLS, OpenVPN is capable of traversing network address translators, NATs, as well as firewalls. It was written by James Yonan and is published under the GNU General Public License, or GPL. Since its release, OpenVPN has become a wildly popular platform, particularly for smaller networks. OpenVPN has a strong community of developers supporting it, and it is very well maintained by the community. This works as an assurance that if there's a vulnerability found, it will get patched quickly. OpenVPN works great on high latency connections. It is also capable of compression in case you have limited bandwidth on the client or server side. OpenVPN is a flexible technology. It supports LDAP, radius, and local user database, which makes it flexible in integrating with different types of environments. If you have a central user management system like LDAP or Active Directory, you could integrate OpenVPN with that system. The advantage here is that the network users do not need to remember multiple sets of credentials. Or you can create a local database of remote users in your OpenVPN server as well. Users can then use these OpenVPN credentials to connect to a remote location. Encryption in OpenVPN is built upon a strong foundation of OpenSSL, which is an open source implementation of the SSL/TLS protocols. These protocols allow us to use these industry standard and strong cryptographic algorithms which are compatible with most systems out there. These encryption mechanisms can be hardware accelerated for better performance. OpenVPN is also cross-platform. It supports Windows, Mac, Linux, and even mobile platforms like iOS and Android. Now let's see what makes OpenVPN different from other VPN solutions. One of OpenVPN's key strengths is that it's highly stable, scalable, and easy to install. Another advantage is that it provides support for dynamic IP addresses and NAT. OpenVPN is an extensible VPN framework. This eases site-specific customization, such as providing the capability to distribute a customized installation package to clients. It also offers a simple management interface, using which you can remotely control or centrally manage an OpenVPN daemon. You can also use the interface to develop a GUI or web-based front-end application for OpenVPN. This makes it easy to use even for non-technical users. On the Windows platform, OpenVPN can read certificates and private keys from smart cards which support the Windows Crypto API. OpenVPN's industrial-strength security model protects your network against both passive and active attacks. The security model uses SSL/TLS for session authentication and the IPsec ESP protocol for secure tunnel transport over UDP. These are all industry-standard protocols which are compatible with a plethora of other products out there.